We'll look at computing z-scores and review the empirical rule. Math SAT scores and Math ACT scores are both known to be roughly bell-shaped. So if we were to make a sketch of what we believe the grades to look like on these exams, we would expect the graph to look something like this for the SAT scores, and similarly we would expect the graph for the ACT scores to also be bell-shaped. What's different about them are the means. The SAT scores are known to have a mean of 505 for this group of students, and the ACT mean score is 18. What's also different is the standard deviation. The standard deviation for the SAT is 100, so I'm going to mark a couple of standard deviations in each direction from the mean. Similarly, for the ACT scores, I'll add and subtract several standard deviations in each direction from the mean. Standard deviation for this group is 6. Okay, so if you remember, the empirical rule is really helpful. It tells us that approximately 95% of students in this population who took the SAT had a score between 305 and 705. So this leaves a remainder of 5% who scored either below 305 or above 705. So if we cut that in half, we know that 2.5% of the students had really impressive scores, those with scores above 705. For the ACT, we can do something similarly. Marking off 2 standard deviations in each direction from the mean, we know that, again, 2.5% will score above 2 standard deviations from the mean. So students who scored above the 30 were in the top 2.5%. So let's look at 2 students' scores. Sam had a SAT score of 700. I can mark his on the graph. It's going to be roughly here. And Anne took the ACT, and her score was 31. Slightly better than 2 standard deviations from the mean. So right away I can visually see that Anne's score was more impressive. She was more than 2 standard deviations above the mean, while Sam was just under 2 standard deviations from the mean. So one last question is, well, what happens if we want to figure out how many standard deviations Sam scored from the mean and the same for Anne? We can use a z-score to do that for us. It's easy to compute. Just take the score for Sam and subtract off the mean SAT scores, 505, and then divide by the standard deviation. If you do that, you get 1.95. You can see just slightly under 2. Likewise, for Anne, her score was 31, the mean on the ACT is 18, and the standard deviation is 6. So Anne's z-score is 2.17. And again, that reflects what we saw in the picture. Her score was just above 2 standard deviations from the mean.